To determine which quadrant holds the terminal side of a standard angle, we're going to draw the angle in standard position and then identify which quadrant it terminates in. Just as a reminder, the quadrants go 1, 2, 3, and 4. So if I'm talking about 45 degrees, I'm going to draw the angle in standard position. Its initial side is the positive x-axis, and then its terminal side is going to swing up 45 degrees. So about right there, making this the 45-degree angle. Since the terminal side is in quadrant 1, this angle terminates in quadrant 1. For 285 degrees, again, start with your initial side as the positive x-axis and move around the circle here. This would make 90 degrees. Terminal side over here would be 180, 270. So I need just a little bit more than 270 to get to 285. This would be my 285-degree angle. Since the terminal side is in the fourth quadrant, this angle terminates in the fourth quadrant. If our angles are measured in radians, we still need to draw the angle of pi over 3. Again, its initial side would be the positive x-axis. But when I'm thinking about pi over 3, that's really the same as 1/3 of pi. And you need to think about radians like this, that pi is going to give us that 180 degrees. So all the way over here is pi. And if I want to find out what 1/3 of pi is, I'm going to take this arc and divide it into thirds. Again. So pi over 3 is going to be this angle. Since that terminal side is in the first quadrant, we say that this angle terminates in the first quadrant. For 4 pi over 3, that same idea. We just found out that this is 1/3 pi, 2/3 pi, 3/3 pi, so 4/3 pi must be down here. We just continue with our initial side to swing this terminal side around the circle until we get to 4 pi over 3. So there's 4 pi over 3. This terminal side is in the third quadrant, so terminates in the third quadrant. But now what about 90 degrees? We know that a 90-degree angle, here's the initial side. The terminal side is going to be straight up the positive y-axis, making our 90-degree angle. But the question is, which quadrant holds the terminal side? Is it in quadrant 1 or is it in quadrant 2? It's definitely not 3 or 4. But obviously, with 90 degrees, that's the dividing line between quadrants 1 and 2. And so it's not in either of those. Instead, we call this a quadrantal angle. So a quadrantal angle is going to be an angle in standard position whose terminal side lies on an axis. In degrees, with one trip around the circle, we have 4 quadrantal angles. First one, of course, being this 90 degrees. As we continue around, if the terminal side lies on this axis, we're looking at 180 degrees. Down here is 270 degrees, and then 360 degrees. In terms of radians, we know that if we go straight across, this would be pi radians. So our 90-degree angle is pi over 2, half of that pi. So we got 1/2, 2/2, then this one would be 3/2 pi, or 3 pi over 2. And when we come all the way around full circle, we're at 4 pi over 2, or 2 pi radians. So that was quadrantal angles. The second big idea here is reference angles, and that is the angle made by the terminal side and the nearest x-axis. If we're talking about the angle 5 pi over 3, now we could draw that in standard position. When there's 1/3 pi, 2/3, 3/3, 4/3, and 5/3. So this angle, going around this way, is 5 pi over 3. For its reference angle, we want to look at the acute angle that it makes with the nearest x-axis, right here. Since the outside here was 5 pi over 3, that means I got 1 pi over 3 left over. And it's that pi over 3 that is this angle's reference angle. If we're looking at it in terms of degrees, again, just draw it real quickly. My negative 130 degree angle, if I go negative, that means I got to swing down. This would make 90 degrees here. I'm going to need another 40 to get over to negative 130 degrees. The reference angle is going to be the angle, the acute angle, that the terminal side makes with the nearest x-axis. So what is this one? Well, obviously, if we were to swing it all the way back to this negative x-axis, that would be negative 180 degrees. I've already used 130 to get back to negative 180. This would be another negative 50 in here. But just so you know, the reference angle is not negative 50. And we always refer to the reference angle as a positive acute angle. So the reference angle here would be positive 50 degrees.